Section 6.4, example 3, graphing a logarithmic function with the form f of x is equal to log base b of x. So graph f of x is equal to log base 5 of x. State the domain, range, and asymptote. All right, so we could always graph these using some key numbers. And key numbers are just going to be numbers that work best for our equation. So here we have log base 5. So what we want on this inside are powers of 5. So 1 power of 5, like the easiest one I could think of is going to be 5. So 5 to what power will give us 5? So 5 to what power will give us 5? That's going to be to the power of 1. Another easy one is like anything to the power 0 is always going to give us 1. So throwing that in here, 5 to what power will give us 1? So 5 to the power 0 will give us 1. So again, here we said 5, this is 1, and that should be 0. So 5 to the 0 power will give us 1. I know it looks confusing, but I promise it will get easier the more of these that you do. Another one, let's go to the negative numbers. So 5 to what power? We'll say the reciprocal, so 1 over 5. So we could think of this backwards. So 5 to the negative 1 power is going to give us 1 over 5. This is what we input, and what we output is at negative 1. So 1 over 5. Again, 5 to the negative 1 power will give us 1 over 5. So this is our output here. And let's try it for the next one. We'll say 1 over 25. What do we raise 5 to in order to get 1 over 25? For the reciprocal, it's going to be a negative. And 25 is 5 squared, so negative 2. So again, 5 to the power of negative 2 is going to give us 1 over 25. And now that we completed all the hard stuff, let's look at the easier stuff. So going up. So 5 to the power of negative 2 was 1 over 25. Negative 1 is 1/5. 0 is 1. 5 to the power 1 is 5. Now let's look at 2. 5 to the power 2. That's going to give us 25. We could do 3 if you want to. Yeah, let's do 3. So 5 to the power 3 is going to be 625. So 5 times 25, 10 or 125. So 125. And from here, we could go ahead and graph. So here, our outputs aren't going to be that bad, but our inputs are going to be a little bit tougher to work with. So let's start with, we'll say this is 5, 10, 15, 20, 25, 30. So we don't even have room to graph this one. But let's start with 25 and 2. So when we input 25, we output 2. So input 25, we output 2. So there's that one. Now let's move on to this one. When we input 5, we output 1. Perfect. When we input 1, we output 0. That's about here. When we input 1/5, we output negative 1. So somewhere around here. When we input 1/25, we output 1 or negative 2. So it doesn't matter how far we zoom in. our pen is going to be even too thick to draw that one. So what I'm going to do is draw it really, really, really close to 0 and just kind of know where our asymptotes are. So here, our asymptote is at x equals 0. We get a color that's a little more vibrant so we could see it. So this here is our asymptote. X equals 0. It's our vertical asymptote. And there we go. So lastly, they want us to identify domain, range, and asymptote. So starting with domain. Domain is all of our values that we could input. So it looks like we can't input anything to the left of 0. So we're starting off here at 0, starting off at our asymptote. Parentheses, because we're never going to actually touch 0. So parentheses from 0 all the way up to infinity. Because as we keep going further and further right, our graph goes further and further right and up, even though it kind of doesn't look like it, but it does go up. So that's our domain. Next, let's talk about the range. So with the range, it's all the values that we output. So as we go closer and closer to 0, to x equals 0, we go further and further down. So here we're starting off at negative infinity. And let's see how far we go up. So we go up, up, up. And even though it looks like we have another asymptote here, we don't have that asymptote there. We are able to grab values all the way up to positive infinity. It's just that these take off so quickly to the right. But we do have values up to positive infinity. Lastly, we have our asymptote. So our asymptote is where our numbers go. Over here, it looks like we're going a lot closer and closer to x equals 0. So asymptote at x equals 0. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.